Stacks are powerful data structures that can help us solve many complex programming problems. We can use them to implement the undo feature in our applications. We can use them to build compilers. For example, compilers use stacks for parsing the syntax of expressions. We can also use stacks to evaluate arithmetic expressions. Let's say we want to build a calculator and allow the user to type an arithmetic expression like this. With stacks, we can evaluate this expression. We can also use stacks to build navigation in our applications. For example, web browsers and Android devices have forward and back buttons. We can implement these buttons using stacks. Now let's look at the structure of stacks. The best way to understand stacks is to think of a stack of books. We can stack a bunch of books on top of each other, but we can only view or remove the top book. If you want to get to the bottom book, we have to remove all the books one by one. This is what we call the last in, first out, or LIFO principle. And this is exactly the reason why we can use stacks for implementing the undo feature or navigation in our applications. Imagine each object in a stack represents an action that the user performed in the text editor. So we have action 1, action 2, and action 3. Now, to undo these actions, we start with the last action. So the last action that was performed is the first one that can be undone. We can take this object out of our stack and call one of its methods to undo that action. Now, internally, we use an array or a linked list to store the objects in a stack. So a stack is basically a wrapper around an array or a linked list that gives us a different way of storing and accessing objects. Now let's look at various operations that stacks support and their runtime complexities. Stacks have 4 operations: push, which adds an item on top of the stack; pop, which removes the item on the top; peek, which returns the item on the top without removing it from the stack; and isEmpty, which tells us if the stack is empty or not. As you can see, we don't have lookups because stacks are not really meant for that. So we don't use stacks to store a list of products, customers, and so on. Now, in terms of the runtime complexity, peek and isEmpty run in constant time or OR1. Push and pop also run in OR1 because we can quickly insert or remove an item at the end of a linked list. The same is true if we use an array to implement a stack. You'll see that later in this section. So all operations of stacks run in O(1). That's all about stacks. Now let's jump in and see the stack class in Java.